Hello, everybody. I want to share with you an interesting lesson I had the opportunity to co-teach in an Algebra 2 class this week. So I was working with a teacher who was going to introduce to the students for the first time solving irrational equations. So we co-designed a lesson together with a whole group of teachers, and then I launched the lesson. And I think there's a couple of things that was interesting about this lesson, and the first of which was the launch. So keep in mind now that the students had never seen solving irrational equations before, and this is how I chose to launch it. So I gathered them up in a huddle around a whiteboard like I normally do, and I wrote up on the board 3x plus 2 equals 14. And then I said, okay, so we want to solve this for x, so what do we have to do? And because these were Algebra 2 students, they were really, really fluid with this. So right away, they're like, subtract 2 from both sides. And I said, okay, we'll subtract 2 from both sides. Why? And they said, because we have to isolate the x. I said, okay, fair enough. So the 2's cancel here. So now we have 3x equals 12. What do we do now? And they said, you have to divide both sides by 3. I said, okay, why? And they said, because we have to isolate the x. I said, okay, fair enough. So then we did that, and we got x equals 4. And I said, this wasn't hard. They acknowledged this wasn't difficult. And then I said, okay, but now I want to check my answer. So what does it mean to check the answer? So we've got x equals 4. What does that mean? And they told me that it means that x equals 4 means that x equals 4 will make that statement true. And I said, okay, so let's double check that. So what we're going to do is we're going to start with our original question, 3x plus 2 equals 14. And we're going to put the 4 into this. So it's going to be 3 times 4 plus 2 equals 14. And then we solve that. That's 12 plus 2. So 14 equals 14. And that is true. So therefore, this answer is correct. And this was really what I really wanted to emphasize in the launch. One of the things I wanted to emphasize in the launch was that solving is one thing. We have to check our answer. Okay, so the second thing I did then in the launch is I said, okay, let's go back to this idea that you subtracted 2. Why did you subtract 2? And they said, well, because we have to isolate the x. I said, yeah, but why subtract 2? I get we have to isolate x. Why subtract 2? And then somebody said, well, it's the inverse operation. I said, okay, so we have these inverse operations. So if we have a plus, what's the inverse operation? And they're like minus. I said, well, what if we have a minus? What's the inverse? They said plus. What if we have times? And they said that the inverse operation is divide. And I said, well, what if we have divide? Then the inverse operation is times. I said, well, what if we have square root of a number? What is the inverse of that? And they said square is the inverse of that. And I said, well, what if we have a square of a number? What's the inverse? And then they said square root. I said, good enough. The first question you're going to solve is square root of x equals 4.2. And what I want you to do when you're solving it is I want you to check your answer. And that was really, really important. I want you to check your answer. Every group had a calculator, and then we sent them off to work on this. And they solved this one. And then they got another one that was similar. Square root of x equals 7.13, I think it was. And so on and so forth. And they just got to work. And then we kept ramping up the complexity of the questions as they worked. Now, I'll share with you exactly what tasks we actually worked on. So you could see that we started with things that were very similar. Then we started adding in sort of two-step things that they had to do inside of the radical sign. And then eventually things that had to come outside of the sign. And then you'll notice we got to these really complex ones. And by the end of the lesson, we had groups solving questions like this. We didn't actually get to the last two. Those were in the plan, but we didn't get that far. But we did have groups working on these two type 3 questions. So I just want to draw your attention to something. I never showed them how to solve something like this. I never showed them how to solve something like this, and I never showed them how to solve something like this. What was important was that all I did was review the purpose of solving was really just to isolate that x and to check their answer. We also reviewed the inverse operations. So although I never really showed them how to do this, we did review this idea that the inverse of square root is square and the inverse of square is square root. What was interesting watching was seeing how the kids actually engaged in this, because when they had a question like that first one, they would sometimes square like that. They would square both sides. Some would put brackets around both and square. And some would square inside and then square on the outside. All of these are correct, and we talked about this in the consolidation at the end. The other thing I want to draw your attention to is that if you notice, every one of these questions has a decimal in it. Now, I took these questions from the resource the teacher gave me, and then I just added decimals here and there. What's the purpose of the decimal? So one of the challenges with algebra is that we are always asking students to solve questions like this. 3x plus 2 equals 14, right? These types of questions. And then we're performing all of these manipulations to isolate the x. But the students are kind of looking at this question and going, well, the answer is 4, duh. So they often don't see the need to perform all of these inverse operations. By introducing a decimal, we're actually setting it up that they do have to perform the inverse operation because they can't do it in their head. If I would have given the first question as root x equals 4, a lot of the students would have just said, well, the square root of what is 416? They wouldn't have necessarily thought about the inverse operations. So by introducing a decimal and giving them a calculator, it forces them to actually perform the inverse operations. The last thing I want to share with you is the way we had the board set up. So we had this common banner at the top. This is where they wrote the question that they were working on. So the first question was root x equals 4.2. That helps me as a teacher monitor what they're doing. Then they had to perform the calculation in this box. So they would solve this here. So in this case, you might go root x equals 4.2, square both sides, take out their calculator, x equals whatever the answer is. And then now they have to check it. So they have to actually take the answer, whatever they got, and they have to start over and they have to plug that in. Now, this is one of the things that we have discovered in thinking classrooms. I think all teachers understand that students don't check their work. We tell them to check their work. They say they check their work. They didn't actually check their work. So by creating a box where we want them to check their work, they actually checked it. And what was really great about this was because we hadn't actually taught them how to solve these questions, they were immediately getting some feedback and knowing whether they were doing something right or wrong. And that became important when we got into these multi-step equations. But nonetheless, we had the board set up like this, and the way it worked was that they were going to do the first question here. They were going to solve it and check it. Then they were going to do the second one here. They were going to solve it and check it. Then they did the third one here, solve it and check it. Fourth one here, solve it and check it. And when they got to the fifth one, they erased the boxes. They erased the work in the first box. And then they got to work on question number 5 here. So this way, it gave us an opportunity to move around the room and monitor lots of work without that sort of frantic running around trying to figure out if the students were doing it correctly. We could see that they were doing it correctly. We were able to give feedback on whether they were doing it correctly. So nonetheless, this was this lesson on solving irrational equations, and the students did great. We covered more than one day's worth of content. The students really understood what they were doing, and we had an opportunity to monitor. And I think my favorite thing about it was that I didn't actually show them how to do it. They just figured it out on their own using these basic understandings that we have to do the inverse operation and then operating in those spaces.